Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is number of islands. It's a medium level question. So let's read the problem statement. We are given with an m into n cross 2D binary grid which represents a map of 1 which is land and 0 which is water. We have to return the number of islands. So island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So let's take an example. Let's see the example to better understand the problem. So let me write this down on the dash on the whiteboard. So here, if you'll see, I have taken the example from the question. So I have represented one as a land. So in the question it says that one is the land and zero is water. So I've highlighted 0 with the blue so that it better resembles the water. Now if you see this piece of land, like this piece of land or this piece of land and this piece of land, you'll better understand that these are islands. How these are islands? So let me first let's understand first the island. So island, if you see this diagram, so this is some sort of water in the blue and this is island that is surrounded by blue. So is this block can be, multiple ones means these can be that this piece of land can consist of many pieces of lands. So if one represents a piece of land and if we combine multiple pieces of land, multiple ones, then we can then see whether it all by combining all those that are directly in touch horizontally or vertically, if they are surrounded by water or not. So yes, if we combine these piece of land, we'll see that these are surrounded by water. Similarly for this, because this piece of land and this piece of land, or this island are not connected. They cannot be connected. So similarly here, if we see this one, this is a piece of land above which that is 0, on the right side that is 0, on the below it's 0, on the left side it's 0. So this piece of land is surrounded by water, right? And if we see this piece of land, on the right side it's 0, on the left it's land, right? It can be connected with land. But if we assume this as one piece, then island this will be an island, because this complete piece of land is connected, this surrounded by water. On the right there is 0, on the right there is 0, on the below there is 0, on the below horizon vertically below there is 0, on the left the out of bound means the grid ends, so we can assume there is a 0 above and below, everywhere out of the grid. So if we assume this as a piece of land, then it will be an island. We will not consider the diagonal elements, so they are not connected. We will not take the diagonal, so we'll only take the horizontal and the vertical. So here, now we understood that what island is. Now how we will solve this problem is, the idea behind solving this problem is, we will first check each uh, uh, value, that is land. If it is land, we'll mark it as 0. We'll say that this land is submerged. We'll keep on submerging this land, will or converting into the water. Now we'll check from this one horizontally and vertically. Are there any other lands connected? Yes. From this uh, 1 at I 0, let's write down the indices as well to better understand it. So at 0 comma 0 0 0 there was a land, we converted into 0, we marked it as water, and we checked whether from this land are any other lands connected. Yes, on the right of this we have another land, so we will make it as water, and we'll again check for this if it is connected with any other land horizontally or vertically. Yes, vertically it is connected with the other land, we'll mark it as 0. We'll check with this one if it is horizontally or vertically connected with any land. Yes, it is connected with horizontally with the land, so we'll mark it as 0. So now there is no land that is directly connected with this island that we can convert into water, right? So this is going to be one island. Similarly, for this piece of land, we'll check, this is a land, we'll check whether this is horizontally or vertically connected with any land. No, it's all surrounded by water, so it's automatically will be one island. Now we'll check for this one and this one. So this one is connected with this land on the right side. So we'll first mark it, we'll make it 0, and we'll see on the right side it's also 0, it's also land, so we'll make it a 0. Now other than this, all the other there is no land which we can convert into water, so this will also be one island. Also this will be converted into 0 and this will be another. So for this we have 3 islands. So if you see what we checked when we started changing the lands into water, we went for 4 directions, 4 DFS, 4 directions, that is left, right, up, down, right, left, right, up, down, so 4 directions. So first of all, what data structure we can think of? So what comes into my mind is graphs, because we can think of this. Let me copy this and paste again so that it's clear. Yes, we can think of this as a all as vertex. This one as vertex, this one as vertex, 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 vertex. We can consider these all these as vertexes, vertexes of a graph, right? So now we have identified that this is a graph problem, and also we got an intuition to use DFS or BFS. Traversal is not important, we can go with DFS or BFS, any approach. So we will go with a DFS approach to perform this activity that we discussed. Like for every land will convert into water, and the attached land, that is if one is horizontally connected with another land, will mark it as 0, or vertically if it is connected with any land will mark it as 0. So in this manner we'll end up with 3 islands in for this example. Now let's see the DFS uh, function calls, so that we can see how DFS will solve this problem. So if we Let me again paste the example. So if we will start for 0 comma 0, so we will call DFS 0 comma 0. So for 0 comma 0, we are at this point, so we have to go in four directions, that is I plus 1, I minus 1, j plus 1, j minus 1, right, left, up and down. So these are, so we go DFS 1 comma 0, DFS minus 1 comma 0, DFS 0 comma 1, DFS 0 comma minus 1. So if we go DFS 1 comma 0, I like means downwards, so we'll mark this as 0. For minus 1 comma 0, minus 1 comma 0 is the left side, that is out of the grid, so it's already 0, so we'll return from there. So we'll return from there. Now 0 comma 1, 0 comma 1 means this one, so we'll change it to 0. For 0 comma minus 1, that is up, that is already 0, so we'll return. For 1 comma 0, for this vertex we'll check again the up, down, left and right uh, vertices, so means we have to call 4 DFS calls again. For DFS 0 comma 0, it will be back up and it's already 0, because for DFS of 0 we'll mark it as 0. Now it will return. For DFS 2 comma 0, for DFS 2 comma 0 it's already water, so we'll return. For 1 comma 1, for 1 comma 1 we'll mark it as 0, and for DFS 1 comma minus 1, so DFS 1 comma minus 1, that is on the left hand side, so we'll return. Again for 1 comma 1, for 1 comma 1 we can have four directions, right, up, left, down. So we can see that from this all the uh, vertices up and down and left and right are 0, so we'll return from there. For return from here, we'll return from here, we'll return from here, we'll do nothing. Now for 0 comma 1, for 0 comma 1 here we can see that all the vertices on the left, right, down are 0, and for the up, out of bound, out of grid will return, so we will return from here. So as you can see that after completing this one DFS call from 0 comma 0, we are able to submerge some pieces of land, right, but some pieces of land are still there, right. So we are able to submerge these pieces of land, so this will be one island. And now to submerge the other island, other pieces of land, we'll do the DFS on the next ith and jth column and ij value, that is 0 comma 1 from this. So from this there is nothing, all is water, this is also water, this is also water, this is water, skip, this is also water, will keep on skipping until we reach here. So from this there is no water, there is no land on the up, down and right, and up, down and right and left, so we'll mark it as 0. And we will do the DFS calls on other ith and jth value until we reach here. So when we reach here we will mark it as 0, and we also mark the corresponding what is connected with 1, we mark it as 0. So when we marked it 0, this one, so this was one island, and again for these piece of island we'll this is another third island. So in this way we will be able to find the number of islands, like how many times the DFS calls that made the lands submerged pieces of land submerged, disconnected pieces of land submerged, those are the islands for us. So let's see the code part of it. So here, for every row and for every column, so we'll first means it's a two for loops, like for each I value and j, for each ij, means from here to here all the values we are traversing. So for each ij we have to do the nums of islands. So for each value I comma j, uh, for every block or every index, like 0 comma 0 0 comma 1, do the we have to do the DFS calls, because they can be disconnected as well. So this is a example of disconnected graph as well. So now for each I and for each j, we will check whether the grid ij is 1. If this is 1, we'll increment our count plus plus and we call the DFS on that grid I comma j. Now in the number of islands method, we are taking the grid as our input and I comma j the row and the column. If the row is smaller than 0, or if the column is smaller than 0, if row is greater than grid dot length, or column is greater than the uh, column's length, or if that is not land at all, if it is 0, if this is 0, that we are going to DFS. So we suppose we are doing DFS for this and we found that it is a 0, will return. So this is our base case. Otherwise we'll mark the land as 0 and we'll perform the DFS on the 4 directions from that piece of land. So simple DFS uh, you know uh, algorithm. So let's try to run the test cases. So yes, the test cases are passing, so it means the code is working fine. So the complexity, the time complexity will be, because we are running 2 loops for this, so the time complexity will be order of m comma n, big O of m comma n. So it will be, the time complexity will be big of m cross n. So thanks for watching this video. Hope you like this video. If you like this video, please share and subscribe. This will give me motivation to present more such videos. Thank you. Bye.